Hi, in this video, I will be showing you problem number 8 of chapter 4 section 7 from the practice exam. Find the dimensions of a rectangle with area 343 meters square whose perimeter is as small as possible. So this is one of optimization problem. So the area of the rectangle is given. So let's assume that the dimensions are x and y. X is the length and y is the width. So let the dimensions of the rectangle, the dimensions means length and the width. So it's given area is 343 meters square. So area of the rectangle, which is length times width, which is equal to 343. So from here, we can solve for one of the variables, which is y we will solve, which is y equal to 343 over x. Then we want to minimize the perimeter of the rectangle as small as possible. Minimize the perimeter, which says that as small as possible. So we are minimizing it. So the perimeter of the rectangle is 2x plus 2y, twice the length plus twice the width. Instead of dealing with two variables, we will change this to one variable, which is 2 times y, which is 343 divided by x. So now the perimeter becomes a single variable problem, which is 2x plus 2 times 343, whatever that number is, divided by x, is the one that you want to minimize. You want to minimize the perimeter. In order to minimize the perimeter, we will have to find out the derivative. So derivative of this function, p of x, which is derivative of 2x, which is 2. And then for the second term, it is 2 times 343. That is going to be 686. So it's going to be 686 to the power x to the power negative 1. So it's negative 1. 686 x to the negative 2. So that will be the derivative of that function. So by setting that to 0, we get the critical number. So it is 686 over x square equal to 2, or 2x square equal to 686, or x square equal to 343 by dividing by 2, or x equal to square root of 343, which is going to be 7 square times 7. 7 cube is 343, which is be 7 square root of 7. That will be the x coordinate. That will be the value of x. That is the value of x, or the critical number or critical point. Now, as the problem is asking us to minimize the perimeter, we can either use the first derivative test or the second derivative test, whichever is easier. In this case, the second derivative may be easy. So we will find out the second derivative. So we have to find out if we find out the second derivative, we have to take the derivative of the first derivative, which is this line. So p double prime x would be equal to derivative of 2, that will be 0. Here it will be negative of negative 2 times 686 x to the negative 3. That will be the derivative, second derivative. So if we write that, so 2 times 686 will be 1372 divided by x cube. X in the context of the problem is the dimension of the rectangle, so which can never be 0 or negative. So it is 1372 over x cube. So it has to be positive for every value of x or throughout the domain. So it is positive throughout the domain. So which is concave upward. The graph of p of x is going to be concave upward. And then at this point there is a local minimum. And in fact it is an absolute minimum occurs at x, which is at 7 root of 7. So there is a, so at 7 root of 7, there is a local absolute minimum is attained. So this justifies that the perimeter has been minimized at x equal to 7 root of 7. So that determines the dimension, which is the length. And then we have to find out the other dimension, which is y, which is 343 divided by x, or 343 divided by 7 square root of 7. So this is 7 times 7 times 7 divided by 7 root of 7. This gives us again 7 root 7. So the dimensions of the rectangle are length is 7 root of 7 and the width is also 7 root of 7 because everything is measured in terms of meter, because the area is given as meter square, so each length and the width should be measured in terms of meter. So this tells us when the perimeter is minimized, the length and width are the same, equal to 7 root of 7 meters, showing that the rectangle becomes a square. Hope this video helps.